Dear student, in continuation of the first chapter, we are continuing that chapter. We learn about the SN2 mechanism, nucleophilic substitution biomolecular reaction, various aspects of that, stereochemistry, factors affecting, and how the attack of nucleophile takes place from backside. All these things we learn. Now, in continuation with this, I am going to start the continuing that is a SN1 mechanism. Now, SN1 mechanism is a nucleophilic substitution unimolecular reaction. That means nucleophilic substitution 1 stands for unimolecular reaction. Therefore, in this case, the substrate is a tertiary butyl halide. OH negative is a nucleophile. It gives a tertiary butyl alcohol and then it will give the Br negative. Therefore, in this case, whenever we are considering the tertiary butyl substrate, react with the nucleophile and it will give you the tertiary butyl alcohol. This SN1 reaction takes place in two steps. The first step is the bond between carbon and Br will break to form the carbocation. Therefore, carbon having positive charge. The first step is slow RDS in which carbocation formation takes place. Only breaking of the CBr bond takes place. Now, second step, the carbocation once formed, then the nucleophile OH negative will either attack from the back side or either it attack from the front side to give the product tertiary butyl alcohol. Therefore, whenever we are considering kinetic study, then in this case, whenever we consider kinetic study of this, the rate of reaction is directly proportional to concentration of the tertiary butyl bromide. That means only substrate. Rate of reaction depends on concentration of only substrate molecule because first step is slow. In slow step, only breaking of CBr bond to form the carbocation. The nucleophile concentration is not involved in the rate determining step. Therefore, rate of reaction depends only on the concentration of the substrate molecule. Hence, only one species is involved in the rate law. Therefore, it is a first order reaction and hence it is a unimolecular reaction. The important features of SN1 mechanism, we can say it is a two-step reaction. The first step is the slow, that is RDS, in which formation of carbocation takes place. Second step is the fast, in which attack of the nucleophile OH negative can take place from both sides, maybe from back side or maybe from front side. If the attack takes place from back side, there is an inversion of configuration taking place. That means if starting having the R configuration, then the product will having the S configuration, exactly opposite configuration. That is called as inversion of configuration. But if front side attack takes place, that means the OH negative approaches from front side to the carbon on the same side of the Br, CBr bond, then there is a retention of configuration. That means if starting having the R configuration, the product is also having the R configuration. Configuration gets retained, remains same. That is called as a retention of configuration. Therefore, if backside attack, there is an inversion of configuration. If front side attack, there is a retention of configuration takes place. Thus, in SN1, there is both inversion as well as a retention of configuration. Hence, it is called as retention and inversion. Says racemization takes place. Means 50% of positive and 50% of negative. Now, whenever we consider the energy profile diagram of SN1, we draw energy versus SN1. Then, in that case, it is a two-step process. Therefore, there are two transition states. This is one TS1 and second is this is TS2. The first step, the energy of activation required from the baseline we are considering, therefore energy of activation will be higher. Therefore, rate of reaction will be slower and therefore it is RDS. Rate of reaction required for the first step is high and therefore it is a slow. The first step is slow. While this is a transition state TS1 for the first step. In second step, the transition state is TS2. But once the carbocation is formed as an intermediate, immediately it gets converted into the product. The energy of activation required for the second step is less as compared to the first step. As energy required is less, it will be the fast step. Therefore, the first step is slow, RDS, while second step is fast. Now, whenever we are considering stereochemistry of the SN1, in that case, whenever stereochemistry, we are considering the starting material must be optically active. Therefore, all the R groups or whatever groups attached to the carbon must be different. Therefore, here one is CH3, one is hydrogen, one is ethyl group, and the Br is a leaving group. Means CBr bond is there. Now here we are treating with NaI. In NaI, Na is a positive and I negative is a nucleophile. Therefore, instead of Br negative, I have taken I negative here. Whenever nucleophile I negative will attack from the back side, then there will be the inversion of configuration. Means this I negative nucleophile comes from back side. Therefore, in inversion, it comes from back side. Whenever I negative approaches from front side, then in product you are getting that is from front side. Therefore, the configuration will be retained. That means whatever configuration of starting material, that will be the same for this retention of configuration. But whenever backside attack takes place, the configuration will become reverse. If starting having R, it will having S, like that. Therefore, in stereochemical point of view, attack of the nucleophile, both side possible, backside as well as front side. Backside attack gives inversion, front side attack will give you retention of configuration. Hence, whenever we are considering SN1 in case of optically active compounds, means asymmetric carbon, all groups attached to that is different, then it become asymmetric, then it become optically active. Therefore, whenever we are starting from the optically active compound and if nucleophilic attack I negative takes place, then it will give the racemic mixture. Means it gives 50% of inversion and 50% of the retention of configuration, which is called as racemization takes place.